Okay, so lesson 15, the remainder theorem. So we're going to do long and synthetic division. So like you were just saying, long division, up until this point, you're like, I never have to worry about that again, right? It actually comes up again. So you guys you forgot about long division. It was like grade 6 probably that you were doing long division last. We're going to do it again now that we're in Math 30-1. Yeah, it won't be so bad. I'll remind you guys, well, our first couple questions will just be doing long division in general. And then we'll apply that to polynomials. So we're going to be dividing polynomials. Okay, so first off, let's just look at, in general, the way it's set up for long division. If we were going 7, like 7 divided by 2 or 7 divided by 2, if you guys remember, we have a symbol for that. We can write it like this, where it's 7, right? And then not square root, but just 7 and then that little symbol there, divided by 2. And you would go, okay, well, how many times does 2 go into 7? And it would be 3, right? And then 3 times 2 is 6, and then 7 minus 6 is 1, and then we always called that the remainder. Do you guys remember, like, you guys know what that means when we say like remainder? It'd be like 3 remainder 1. I think sometimes we did a bad job explaining that when you guys were in grade 6 what that meant for remainder. But what that really is that means 7 could be thought of as 3 times 2, right? Because 3 times 2 is 6. And then the remainder part of this just means that we would have to add on 1. That's like the remainder. It's like the adding part of it. It's like what's left over to like add. Okay? So we're gonna be using that same idea. Now, these things have specific names. So the dividend is the number that you're dividing. Okay? The divisor is the number that you're dividing it by. And then the quotient is what you get out. And then the remainder would be what's left over. Okay, so just we have to get those terms kind of figured out in our mind here. Now, another way of writing this would be, okay, the dividend, so this is like what I wrote up here, right, would be 7 is equal to, and then the divisor would be 2 times the quotient would be 3, and then plus the remainder is 1. So we could write it out that way as well. Okay. Now, divide 327 by 12 using long division. Okay, so this was on the grade 6 PAT, just so you know, this question. So let's see if you guys can get it. So this would be, so we'll write out our symbol there, and it's 327, and we're going to divide it by 12. All right. Does anyone remember what our first step is? Yeah, how many times does 12 go into that? But that's kind of tough to figure out the whole thing. I'm just going to start off by saying, how many times does 12 go into 32? Yeah? Okay, so how many times does 12 go into 32? 2 times. So we're going to write it over the second, like the 10 spot there, right? So it goes in 2 times. And then we're going to go 2 times 12. And then we write that below the 32. So 24. Like that. And then what do we do? Yeah, subtract now. We're going to go 32 minus 24. Okay, so we're going to have 8. And then who remembers the next step here?
Bring the 7 down.
Bring the 7 down. You guys remember. Bring the 7 down. Now what? Yeah.
How many times 12 going to 87?
Right, how many times is 12 going to 87? Okay, so 7 times. And then we're going to go 7 times 12 is 84. And then again, we'll subtract, so we get 3. Okay, so the answer here is 27, and then like remainder 3 is the way you would have seen that. And I remember, and that was always like confusing, I remember as a kid too, because I always thought that was like 27.3. That's not what that means, right? So 27 remainder 3 really means that I could rewrite 327 as 12 times 27 plus 3, right? That's my remainder 3. Just means I got to add 3 more to get to that number. Okay? All right. Now, let's do it with polynomials. So, lots of similarities here. So, if we took this polynomial, so we'd write it out. So, We'll write out our symbol again. And x squared plus 7x plus 17. And then we're going to divide that by x plus 3. Okay. Now what we're going to do is, it's something similar, but what we're going to be looking at is how many times, well, look on the last one, right? We were saying how many times does 12 go into 32? Now what we're going to be saying is how many times does x go into x squared? Right? And really I could be saying like how many times does x plus 3 go into x squared, but the plus 3's on the end on this, or the plus 3 on the end of this one is going to be kind of irrelevant here. So it's really like how many times does x go into x squared? So how many times does x go into x squared? X times. Yeah. X times x is x squared, right? So it goes in x times. Does that make sense? Because I'm saying like x squared divided by x would be x. Or the other way around, x times what would give you x squared? So that would be x. So if it goes in x times, the same way that in the top one, we had to put this over top of like the 10 spot, we're going to put this over the x spot. So it's going to be over top of this one. So it'd be an x like that. Okay. Now, following the same pattern that we did in the last one, right? Remember when we put the number up here, we said, okay, it was 2. And then we went 2 times 12 to get that 24. We're going to do the same thing here, but we're going to go x times x plus 3. Right? So as a polynomial, x times x plus 3 would be x times x and then x times 3. So that would be x squared plus 3x. And then with the next step, remember we subtracted? We're going to do the same thing. But when we subtract, just be careful in this part because we're subtracting that entire polynomial. So you would have to like distribute that negative into both, or just remember that when we're doing this, we're really subtracting both of these. This is like x squared minus x squared, and this is like 7x minus 3x when we do this. Okay, so x squared minus x squared is 0. That was the point. That'll always happen, right? Those ones should cancel out. But then we'll be left here with 7x minus 3x is 4x. Anybody want to guess what the next step is here? Yeah, bring down the 17. Yeah, so it would be similar to before, right? Bring down the 17. So plus 17. Okay. And now we're saying how many times does x plus 3 go into 4x plus 17? And again, yeah, what do you think?
4?
Yeah, they'll go in 4 times, yeah. And again, the 3 and the 17 might confuse people there. They're kind of irrelevant. We're really just looking at the x terms here. So this is going to be like how many times does x go into 4x is really kind of what you're looking at. You're looking at like the numbers out front of those ones, okay? So how many times does x go into 4x? And that was 4 times, so plus 4. And then we'll do the same thing. 4 times x plus 3. So 4 times x is 4x, which is a good sign. And then 4 times 3 is 12, positive 12. And then remember, we're subtracting, so put that in brackets. And then we're left with, so 4x minus 4x is 0. And then 17 minus 12 is 5. And there you go. We just divided polynomials. So let's just kind of look at like that. That looks kind of messy. It's kind of like lost in what I just did there. What this really means, right, is that if I divide this polynomial, it's made up of x plus 3 times x plus 4 with the remainder of 5. So I'm just going to write that out again so we can see what that means again. So this is saying x squared plus 7x plus 17 can be made up of, right, x plus 3 times x plus 4, but a little bit more, right? We need that remainder. So that remainder was tacked on the end, so plus 5. That's our final thing. Those two things plus the remainder.
So the constant term doesn't matter because if it was like, instead of 17, if it was like 10 or something where 3 wouldn't go into it?
It doesn't really get any harder than that. They might just be longer, right? You just might have more steps. That just might be like a longer tree. But if you got that skill down, then you guys will get questions like that one. So, okay. I was pretty much saying this up top, but this is really just saying the same thing, right? The polynomial, p of x, is made up of the divisor of x, right? Because this is now like a polynomial. That was x plus 3 in the last case, times the quotient of x plus the remainder. So just written as functions for each of those. Okay. Now, if the remainder is 0, this is going to be a common theme. We're going to be doing tons of this. If the remainder turned out to be 0 there, like if this ended up being 0, then what you would say is that these are just factors of this, right? That would just be the same thing as factoring it, right? When we factor things, we kind of are like dividing it already, right? When we do that. So those would just be factors. If it's not, then those aren't factors, right? Because, yeah, that's not, it has to be those two things multiplied together to give me my number. So, yeah, if there's no remainder, then those are factors. If the remainder is not 0, so it's like some number, then they're not factors. And the degree of the divisor must not be greater than the degree of the polynomial, and the degree of the remainder must not, or must be less than the degree of the divisor. But, okay, now let's look at this example. So it says, looking at the previous example, if x plus 3 is a potential factor, so potential factor means we're thinking it might be a factor of this polynomial, what is the potential 0? So what, do you know this? So what we would do here, if we have a potential factor of x plus 3, then a potential 0 here would be x is equal to 3. Right, that would be like we've been doing before. Like if factor is x plus 3, then we'd say then there's a 0 at 3, right? Whenever we do those things. Oh, sorry, negative 3, yeah. Thanks. Just testing you guys. Okay, so if we put this in now, so p of negative 3, then we could say, okay, p of negative 3, and we'll put negative 3's in everywhere that there was x's in our original function, this one, right? So then that would just be negative 3 squared plus 7 times negative 3 plus 17. And we'd end up getting that equal to 5. Do you guys see what the relationship is there between what we just did? Yeah.
5 is the remainder.
Yeah, 5 was the remainder, right? The remainder in the last one was 5, right? That value, what was left over was 5, and that's when we divided by x plus 3. So if we put in, like, it'll always be the number that we put in for the potential 0 there will be the remainder. Whatever comes out will be the remainder. The remainder is kind of like your y value, right? It's saying how high above you the graph you are. Does that make sense? Okay, so let's do more. All right, so now let's just do it again. So it says, here's a polynomial. We're going to divide by x minus 2. But now they want us to express it in just like a different way. This is actually the same equation. Can you guys see if I multiplied everything here by x minus a, and x minus a? Then that would just be, so those would cancel. Those would cancel. And I'd have back my original equation of p of x is equal to quotient of x times the divisor of x times the remainder. It is the same equation, it's just written differently. And this is kind of like a common way to write it. You'll see this like on the diploma and stuff. They just want you to find your answers and then just write it in this form. So let's just divide it. So we'll do it again. We'll write out our symbol there, and we've got 5x cubed plus 10x minus 13x minus 9.
13x squared.
Oh, thanks. Oh, shoot. Yeah, and thank you. We need to rewrite this in descending power of x, right? So I should have written this out as 5x cubed and then minus 13x squared plus 10x and then minus 9. And then we're going to divide that by x minus 2. So I'm looking at, so I've got set up, and what am I even thinking? I'm trying to see, okay, how many times does x go into 5x cubed? That's really what the question is here, right? So how many times does x go into 5x cubed? Yeah.
5x squared.
5x squared. Perfect. It goes in 5x squared times. Because you can think about it this way too, right? X times 5x squared would be 5x cubed. Right? They go into each other? All right. Okay, so 5x squared. And I'm going to put that over the x squared spot. And then I'm going to go 5x squared times my binomial there, right? So that's going to be 5x squared, which is a good sign, minus 10x squared, or cubed, sorry, minus 10x squared. And then remember that we are subtracting that. Okay, so those cancel. And we're going to go 13x squared, and then careful on this one. This is minus negative 10x squared. So that's really the same thing as adding, right? So we're going negative 13 plus 10 in this case. So that's going to be negative 3x squared. And then we're going to bring down the 10x. So plus 10x. And now we're asking ourselves, how many times does x go into negative 3x squared? Yeah, and negative 3, right? So it's going to be negative 3x. Okay, and then again, we're going to go that times, so it's going to be negative 3x squared plus 6x, right? Negative 3x times negative 2 would be positive 6x. And then again, we're subtracting all of that. So negative 3x squared minus negative 3x squared, that's like adding, so those cancel, so that's good. And then negative 10 minus 6 is going to be 4x. Bring down the 9. So minus 9. And then how many times does x go into 4x? Goes in 4 times. And then 4 times that is going to be 4x minus 8. We'll subtract that. So negative 9 minus negative 8 is going to be negative 1. All right, so now we've got all of our things. Let's just write it out in this form now. So this is saying p of x, which is just our original polynomial, right? That's just our original. So it's going to be just 5x cubed minus 13x squared plus 10x minus 9 divided by, and then it's divided by our divisor, right? It's divided by x minus a there. So that was x minus 2. And that's equal to our quotient, so what that came out to, right? So 5x squared minus 3x plus 4. And then plus our remainder, which was negative 1. And then over x minus 2. There. All right. So let's keep going. You know what? I'm not gonna answer this B one. I think it's kind of I'm not gonna worry about it. I think it'll be confusing. Let's evaluate P of 2. So if we evaluated P of 2, like the potential 0, 2, right? Because we're comparing that to x minus 2, right? That as a factor. Then P of 2 would be equal to 5 times 2 to the power of 3 minus 13 times 2 squared plus 10 times 2 minus 9. And you want to take a guess at what that comes out to without even a calculator after what we've just done? Yep.
-1.
Comes out -1, right? It would come out to whatever our remainder was in the first one. All right, next one. Now let's put this to some practical use. So.
Oh, yeah.
Okay, so quite often this is volume, right? So like, and the reason for it is volume of a cube or a rectangular prism or something is length times width times height, right? So that's 3 factors. So if we had a polynomial that had a degree of 3, I could rewrite that as 3 different factors. So quite often it has to do with volume when we do these. So it says the volume of a box in cubic centimeters is given by this function. What are the possible dimensions of the box in terms of x if its height in centimeters is x plus 1? So just to get a feeling for this, I'm going to draw out a box. Okay. Now, what this is saying is, so the dimensions, right? So volume is equal to length times width times height, right? So that's like one dimension times the other dimension times the other dimension there. And they've told us that the height in this case is x plus 1, right? That's like one of our dimensions. And we want to figure out what the width is and what the height is. So I want to rewrite this thing as something times something times something. Really what it's asking for is just to factor this whole thing. And we haven't really up until this point known how to factor things with a degree of 3, right? We factor things all the time when it's a degree 2. It just gets harder the higher up we go here. But that's the idea. So let's divide this. So let's divide this by x plus 1 and see what we get. So if we go, let's do the same thing as before. X to the 3 plus 7x squared plus 14x plus 8. And we're going to divide that by x plus 1. Here, I don't need the brackets on that. Okay, and then just remember what we're doing here. So when I divide this, what we're going to get is, well, x times 1 times some other polynomial will multiply together to give me this. So I'm expecting something squared, right? This is going to be like x squared plus something x plus something, right? I'm expecting like a degree 2 polynomial out of this. Okay, so let's divide this one. So we'll go, how many times does x go into x to the 3? It goes in x squared times. And then x squared times x plus 1 is going to be x plus 3 plus, and then x squared times 1 is x squared. Don't forget to subtract them. So those cancel. So we end up with 7x squared minus x squared, so 6x squared. Bring down the 14, so plus 14x. And then we're really asking ourselves, how many times does x go into 6x squared? So how many times does it go in?
6x.
Yeah, 6x times. And then 6x times that is going to be 6x squared plus 6x. And then we'll subtract that. So those cancel. So 14 minus 6 is going to be 8x plus 8. After I bring the 8 down, sorry. And then how many times does 8 go into 8x? 8 times, so plus 8. 8 times that is going to be 8x plus 8. So subtract those, I get 0. Perfect, right? This wouldn't have really worked out at all if it didn't, right? Because we want that this, we're assuming this thing is factorable, right? It's something times something times something. So if this didn't work out to be 0, then it wouldn't have really worked out that I would have had like a nice x plus something or x minus something as a factor there.
So now to find factors, do you just factor the normal polynomial?
Nice, yeah, good job. Yeah, so So let's just write out what we got there for a second. So now, if we factor this guy, right, we could say v of x is equal to, well, I know one of my factors is x plus 1. And the other one is what I just found there, right? X squared plus 6x plus 8. Okay, well, there's my length, is that one, right? And then my width must be made up of those two, but you guys have done this before, right? Can't we just factor this now that we're looking at a quadratic? Let's just factor that. So we could say that's the same thing as x plus 1, and then I'll just put my brackets down, so x and an x. So multiplies to 8, adds to 6, 4 and 2, so 4 and 2, and they're both additions. There we go. We just factored a quadratic, or sorry, a cubic polynomial. So then in the end here, possible dimensions here would be our height would be, well, they gave that to us, right? X plus 1. And then our length would be, they never really told us which is which, so we could say x plus 4. And then our width would be x plus 2. But the length and the width could be the other way around. We don't really know which one's which, right? Okay. You guys are good with that? It's always a tough concept, so it's good. Okay, now that we've been reminding you guys how to do like long division, I'm going to show you an easier way.
Great.
This will typically be the way that you would do these. It's so much quicker. Get you the same result in the end. But there is
So
just
why does the other one exist?
well, because that's really what's happening. So like really this is what we do, right? We do, like, this is what's happening fundamentally. But this synthetic division is kind of like a little shortcut. It's just kind of taking advantage of some of like the patterns that are happening in that. So we can just kind of do it really quick and easy here.
So we learn the long division to appreciate synthetic division?
Well, yeah, because synthetic division is doing that. It's just doing it like with a little algorithm, if you like, right? It's just doing it like a little quicker. So here's how we're going to do with synthetic division. So we will, we're going to write, this is brand new. This is going to seem weird to you guys to begin with. We're going to draw like a box, like upside down kind of a box like that. Okay, so now instead of writing out 2x cubed and 3x squared, 4x, and 15, we're actually only going to put the coefficients into this. So that will be like a 2 would go there, and leave like a little blank underneath it, like that. So a 2 will go there, and then a 3 would go next, right? So that's like the 2 for the first one, 3 for the next one, -4 for the next one, and then 15 for the last one. Okay, and now instead of the thing that we're dividing by as being x plus 3, we're going to put in like the potential 0 there. So that would be -3. We're going to put that right here. So -3. Okay, now follow my steps here. This is always the one that people forget. The very first thing we do is we're going to take the 2 and we're going to bring it down. And we're just going to put the 2 there. This will make more sense once I actually get an answer here, what I'm doing. So, okay, so bring the 2 down, and then we're going to go -3 times 2. So -3 times 2 gives you -6. And you put it right there. Okay, now we're going to go, like, we're going to add these. So 3 plus -6, or 3 minus 6 is -3. And then what do you guys think the next step would be there? Anyone see the pattern that we were doing there yet? Yeah, it's going to be -3 times that now to get to put the 1 in there. So -3 times -3 is 9. -4 plus 9 is 5. Okay, and then -3 times 5 is -15. Perfect. 15 minus 15 is 0. Okay, so now what did we just find there though, right? Remember, like, when we were looking at this, right? This first spot, this was like our x cubed term. This was x squared, this was x, and then this was our constant. Okay? Now, what happens when we do this, it's going to start with the constant in this case, is going to be the number on the end. So this would be our constant. This would be our x term, and this would be our x squared term. And then the remainder was 0, right? Which I don't have to write down. Okay, so now we can just write this thing out. So the answer here was just 2x squared minus 3x plus 5. And that's it. So that is, so if we divide this by x plus 3, we would get the quotient of that. Yeah? So it's quick and easy. Like I know right now it's like a brand new thing. You're like, what just happened? But once you get those steps down, it's really fast. Okay, so evaluate p of 3, or p of negative 3. So p of negative 3. Anybody want to take a guess at what we probably should get for an answer? Yeah. 0, right? We found that the remainder was 0 there. So if negative 3 is a potential 0, then I'm expecting this is going to come out to 0. But we could put it in. So we go 2 times negative 3 to the power of 3 plus 3 times negative 3 squared minus 4 times negative 3 plus 15. And that, in fact, does come out to 0. All right, let's do it again. Okay. One thing to note, though, and I'll do that in this example, that when we're doing synthetic division, it has to go down by, like in the last one here, it went x to the power of 3, x to the power of 2, x, and then constant. It has to go down in descending power of x. But in this example, we've got like x to the 4, x to the 3, and this one just doesn't have an x to the 2. We still have to put it in there. We just put a 0 in the spot. It's like it has a coefficient of 0, right? But you have to include it. Okay? So let's do that one. So using synthetic division, let's do this one again. Actually, you know what? Let's rewrite it in descending power. I'll help you with that one first. So that would just be 3x to the 4, and then minus 2x to the 3. And then you could think about this like plus 0x squared, and then minus 4x, and then plus 13. All right, can you guys take a minute? And so, here, I'm gonna erase those. So did you guys have this written out with the 0 in that spot for the x squared spot? Okay, perfect. So then at this point, we just bring down the 3 is step number 1. So bring down the 3. 1 times 3 is 3. Negative 2 plus 3 is 1. Now 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. And then 1 times negative 3 is negative 3. So now 13 minus 3 is 10. Okay. So that didn't work out nicely, right? So I can't really say that this is a factor, right? That's not going to be a factor of this polynomial. So we can say that the quotient here, though, would be, so q of x would be 3x cubed, right? So here, let's do that too. So this was our remainder. This was our constant term. This was our x term, our x squared term, and our x to the 3 term, right? So now our quotient would be 3, like 3x cubed plus 1x squared plus 1x minus 3. And then it just has a remainder, like a remainder, Rx, would just be 10. Okay. Now, So formally, like we've been kind of doing a lot of these things now, so we're going to talk about like a remainder theorem and a factor theorem. I've kind of like shown you guys the gist of everything now. We're just going to be putting it a little bit like more formal terms now. So the remainder theorem is when the polynomial in x, so p of x, is divided by a binomial in the form x minus a, the remainder is p of a. Well, that's exactly what we've been doing. So remember, if the remainder equals 0, then the potential factor is a factor of x. So that really is the remainder theorem. It's just that if the remainder is 0, it is a factor. Okay? So use the remainder theorem to determine the remainder when this is divided by x plus 4, then verify using synthetic division. So, okay, so we could say p of negative 4 is equal to negative 4 to the power of 3 minus 10 times negative 4 plus 6 is equal to negative 18. Okay, and if we were going to do that using synthetic division, we can do the same thing. So there's actually lots of methods to do these things, right? Lots of ways to answer. So the other way we could do this is we could say, okay, in our first spot, that'd be 1. I don't have an x squared term, so I'm going to put a 0 in for that one. And then negative 10, and then 6. And we're going to try out negative 4. So I'll bring down 1. Negative 4 times 1 is negative 4. 0 minus 4 is negative 4. Negative 4 times negative 4 is positive 16. So negative 10 plus 16 is 6. And then negative 4 times 6 is negative 24. And then 6 minus 24 is negative 18. Perfect. Right? The remainder was the same for both. So we would say that x plus 4 is not a factor of this polynomial. You could also do long division, right? There's like three different ways that we could have found that remainder in this case, right? Okay. Now, just like a little twist on this. Whoop.
Do we ever have to divide by a...
Okay, so now just a little twist on these questions. Okay, so it says if the polynomial p of x is this, and we don't know what the coefficient in front of the x term is, so we just put in m for now. If that's divided by x minus 3, then it tells us the remainder, and it wants us to find that value of m. Okay, so what we can do here, we know some things, right? We know that if we try out the potential 0 here of x is equal to 3, right? If we put in p of 3, then that's going to be equal to the remainder. That's going to be equal to negative 2. That's what's going to come out on this one. So let's actually just write this whole thing out. Let's write out p of 3, right? So we'll write out, okay, so p of 3 is equal to 3 to the power of 3 minus 4 times 3 squared plus m, which I don't know, times 3 plus 10 is equal to what? Yeah, it's equal to negative 2. So perfect. I can see now I've got all numbers in one variable, right? I got one thing to solve for now, right? So we should just be able to do some, straightforward algebra to just solve for m here. And if you do, you know what, I'm going to jump to the chase because this is getting long. I think you guys will be all right. We'd end up with m is equal to negative 1. Okay. Now, the question below is going to be similar, but there's a little thing to it. So it says, for what value of k will the polynomial this, right, where there's a k for a coefficient there, have the same remainder when it's divided by x plus 2 and by x minus 1? Okay, so what this is saying is that whatever p of negative 2 equals, right? For a remainder, I don't know what it is. But it must be equal to whatever P of 1 is, right? Those two have to be equal to each other. Whatever they come out to will end up being the same number. So that's kind of like the start of my equation here. This is a lot like physics 30 where you kind of set them up to begin with, and then we'll work our way down.
Like the momentum part.
It's like, yeah, exactly. So we can, that's like, this is like the start, right? This is probably the hardest part, is just figuring that out, where you set those two things equal to each other. And then what we're going to do is we're just going to rewrite P of negative 2 as, well, the equation with a negative 2 in for all the x's. Okay, so we'll just rewrite that part out. So that would be negative 2 to the power of 3 plus 6 times negative 2 squared plus, and then I don't know k, times negative 2 minus 4. And that is all equal to P of negative 1. So I'm just going to do the same thing but put 1's in. So this would be 1 to the power of 3 plus 6 times 1 squared plus, and then I don't know k, times 1, and then minus 4. Okay, so I've got two variables this time though, right? Like I've got k here and k there. What do you guys think is like a general strategy? What are we going to have to do at some point? Yeah, we're going to have to combine those like terms, right? We got to turn them into 1k. So really, like as a strategy, I want to get the k's to one side, collect like terms, and then kind of do some algebra from there. So let's just simplify this down a bit. If you simplified this side down, you'd end up with 12 minus 2k, right? Just simplifying all that down, is equal to, and then simplifying all this down, we'd end up with 3 plus k. I'll add 2k to both sides. So plus 2k plus 2k. So we get 12 is equal to 3 plus 3k. And then solving for that, you'd end up with k is equal to 3. All right, that's it.